Alrighty, so we've got a retirement account that makes an average annual return of 10.7% annual compound interest, and I'm saying that this is a realistic return. So here's, if you click on here, you can see the average 401k is a type of retirement account that a lot of people have, and you can read about different returns there. So the first step is convert 10.7% to a decimal. So 10.7% is basically 10.7 per 100, 10.7 hundredths, or 0.107. So you move the decimal point 2 spots to the left. So that's what that is as a decimal. Now, let's think about if you put $1,000 in the account, what would be the interest after 1 year? So see if we can all figure out what's the interest.
We're doing it for compound. Wouldn't it be?
Just do it for 1 year.
Okay.
Because that's what we're working with. There's no monthly or anything. It's not semi-annual. It's not quarterly. It's just annual return. So we'll just do it for 1 year. What would be the interest after 1 year?
So you would times 1,000 by that decimal, right?
Yeah.
Okay.
Yeah. So it'd be you just go 10.7% of 1,000, and that gives you $107, or it's just 107 times 1,000. So after 1 year, we'd have $107 in the account. Now, interest though, that would be the interest. Sorry, how much? The question is, how much would be in the account altogether at the end of 1 year? Right. How do you get that? So 1,107 would be in there at the end of the year. How do you get that with just one calculation? Yeah. Right. Okay, so one calculation to show me what would be, to figure out what would be in the account after 1 year. So $1,000 times what? So it's times 1 plus 0.107. Does that make sense? Because it's kind of like a distributive property. If you were to distribute this, that would be 1,000 times 1, 1,000. 1,000 times 0.107 is your $107. And that gives you your total 1,107. Does that make sense? So after to get the amount at the end of 1 year, it's 1,000 times 1.107, and that is the key to a lot of these formulas with compound interest or exponential growth or exponential decay. You got to think about 1 plus or minus something, right? Does that make sense? So that's what's in there after 1 year. Now just figure out what's in there after 2 years. And it's going to look something like this. So after 2 years, what's in there? You take your 1107 and you multiply it by 1.107, right? Or in other words, 1 plus 0.107. Because what's happening is you're getting your same $1,107 back after the first year, but you have interest. So you have to get interest 0.107 times that amount. This is the second year. What's in there? You know what I mean? Yeah, I'm still here. Yeah. So you're getting your same. So on the second year, you're getting what you had at the end of the first year, plus 10% of what was in there at the end of the first year, right? Right. So it's just that's that's what we'll have after the second year, right? But what that is just it's this. It's the amount that was in there after the first year times 1.107, right? Make sense? That's what's in there after the second year. Now, how do we get the first year? How do we calculate 1107? What do we do? How did we come up with this number here that I shaded, 1107? How did we come up with that number? We went 1,000 times 1.107. Okay. So to get what's in there after the second year, so this in blue is the same thing as this in blue, isn't it? This shaded, the same thing as this shaded, right? That's that number there. So this is how we get what's in there after 2 years. How would we figure out what's in there after 3 years then? Yep. Yeah, and that's what's in there after 3 years. How about 4 years? Right, yep. So it's handy. When we do the 1 plus thing, it's handy. You just multiply things. You don't have to add or it's not messy. It's simple. Now, I want you to write this down with an exponent though, because you have the same number times itself 4 times. See that? So how would you write that as an exponent? So let me put it this way. If you had 5 times 5 times 5 times 5, how would you write that with an exponent? Yeah. 5 to the power of what though? 4, because there's 4 5s. 1, 2, 3, 4, right? So what about 10 times 10 times 10? What's that? Yeah, right? So how do I write this expression with an exponent? Yeah. And when I calculate that, it gives me the same thing, 1,501, or almost 1,502. That's what's in there at the end of the 4th year. Agreed? Okay. So, but where did I come up with the $1,000 anyway? Because it's not in the question. See, I made it up just because it's a simple number and I just want to try to understand this thing, right? So what if we use the same interest rate, but instead of that we invested $54,895, right? And we invested it for, say, 9 years. What would this look like? It would be that times what? Yep. Perfect. And there we have $137,000, right? What if, and by the way, that is, if you stuck this money in a retirement account when you're age, say, 56, and then you retire when you're 65, that money would have increased to that amount of money if you were making 10.7%. Which is very risky, because sometimes stock market goes way up, like 20-30%, sometimes it goes way down. So if you're investing money for, say, 39 years, now you're safe. But if you invest just for 9 years, it's hard to know. There could be a downturn in 9 years' time, and bang, your money could be reduced, right? So long-term investing is generally safer than short-term and all that sort of stuff, right? Okay, sorry. So the question is, if we invest P for T years, what would the formula look like? So instead of 54,000, we've got P, right? So it's going to be P times 1.107 to the power of, and so it's, yeah, T. T represents the years, right? Exactly. So anyway, after all that, that's what it is. This here, right? B. But I know this took a long time, but I feel like, you know, this is a key concept. You're going to see this over and over and over again. So it's good we went over it. So.